Hi, my name is Tracy Pratt, and I'm a math teacher in residence at NumWorks. Thank you so much for joining me. In today's webinar, we're going to do a deep dive into the Grapher application. If you have any questions about this webinar or NumWorks in general, you can reach me at my email address, tracy.pratt@numworks.com. For today's webinar, I'm going to use our free online emulator. If you're following along, feel free to use your handheld, the online emulator on our website, or our free mobile app. To begin, let's get started in our Grapher application. Our Grapher application is organized into 3 tabs. Expressions lets you input your elements, the Graph tab where you view your graphs, and the Table where you see your table of values. To begin, we're going to start by adding 2 functions. Press OK to add an element. Here we see our templates of expressions we can type in. I'll use my function f of x equals x template and press OK. The first function I'll add is a quadratic. So I'll do x squared minus 2x. I'll use my xnt key to get another x, minus 14. Press execute or OK to confirm your function. Let's add another function using our same template. This function I'll make into a trig function. So I'm going to clear out my x and create my sine function. Now our 2 functions are inputted, let's go down to plot the graph. NumWorks uses an auto-zoom algorithm that will always display your zeros, maximum values, intersections, and a few cycles of periodic functions. We're also immediately in trace mode. We can use our left and right arrows to scroll through the graph and our up and down arrows to change graphs. In trace mode, you can use your left and right arrows to navigate to points of interest. Points of interest will include intercepts, intersections, zeros, and extreme values. You can also use your store key to store any of these values to reuse later. Just press Shift, followed by the X to the Y key, and then use your alpha key to create a variable. I'll do alpha B, and then press execute or OK to confirm my variable. You can also jump directly to an X value using your number pad. For example, pressing 6 and then execute will move me to x equals 6 on my g of x function. In this window, our plus and minus key act as a quick auto zoom. I can zoom in using my plus key and out using my minus key. Because of this, if I want to jump to a negative value, I'll first input my value and then I'll add a negative sign in front. So to jump to -6, we'll put 6 with a negative key, execute to go to x equals -6. If you want more options of changing your graph more than zooming in and out, you can use your axes and navigate submenus. Let's navigate up and first open our axes. Here, we have the option of making our axes equal, meaning our scale will be square. We can also edit values of x and y individually. For example, let's make our y maximum value 90. I'll go into my y values, and in my maximum, I'll type in 90 and then execute. Confirm, and then I'll confirm my windows. The other way we can adjust our windows is in the navigation submenu. Scroll over and press OK. This window will remove all banners. The plus and minus still work as zoom, so you can zoom out and in, and you can use your arrows to pan the graph. So I can press down to move my screen down. Press OK when you have your windows the way you want it. Now let's take a look at our Calculate menu. I'm going to use my arrows to navigate up and over to my Calculate window and press OK. In the Calculate window, you first need to choose the function you're interested in calculating. We'll select f of x for now. The first calculations we have are inputs for x and f of x. Here we can change the value of x and see that on the graph. We can also change the value of f of x. For example, I'm interested when f of x is equal to 15. I'll press execute. That's going to take me to the y value 15 and the x value -4.48, because that's where f of x equals 15. I know because this is a quadratic, there's another place where this function is going to equal 15. I can use my right arrow to toggle to that value. Here, I can toggle back and forth between the 15y value on the f of x function and this x given y feature. Let's press OK to finish with this feature. To get back into my Calculate menu on my quadratic, I can go back up to Calculate again, or I can simply press OK on the function. Again, we have our editable values, and then we have our Find menu. Let's take a look at our Find menu. In our Find menu, this allows you to zero in on certain features of your function. For example, we just did an x given y when f of x was 15. You can also explore your intersections, your maximums, your minimums, and your zeros. Whenever you calculate on a function, you'll notice that we'll always snap to those values. For example, pressing OK on 0 takes me to the 0 of the quadratic. This function has two zeros, so I can use my right arrow to toggle to the other 0, and then my left arrow to toggle back. Pressing OK again and OK to open up that Find menu one more time, we'll see options for calculus features down at the bottom. I can draw a tangent line on my curve. I can calculate an integral on my curve, and I can calculate the area between two curves in this Find menu. We'll take a look at the area between two curves. I'll press OK. When finding the area between curves, you first need to select your lower bound. You have two options for this. You can use your arrows to toggle to a value. The benefit of this is it will always snap to an intersection. So I'll start with that first intersection and press execute. The other way to select a bound is by using your number pad. So I can go to 6, or I can even go to that stored value that I stored earlier. For instance, alpha b is what I stored as that maximum value, and then press execute. This will calculate the area between the f and g functions. Once my area between curves is done, you can press execute to go back to the graph. Now that we've explored our Find menu, let's take a look at our options. To take a look at our options, I'm going to do this on my sine function. So I'm going to navigate to my sine, and I'm going to press OK on my sine function. Here you'll see for g of x, we have those same editable values, the same Find menu, but for this problem, we're going to take a look at our options. Press OK to open your options. In our options, we can change the color of the function. We can toggle on the value of the derivative. This will update my bottom banner to not just include x and g of x, but this would also include the value of g prime of x as I scroll through my graph. We can do a plot restriction. We can turn this function off in the table and graph, and we can delete the expression altogether. Let's take a look at our plot restriction. Press OK. For this function, the auto is set to negative infinity to positive infinity. If I want to change this, I can simply edit over these. For example, I'm interested in going from 0 to 2 pi. And I'll hit execute to confirm. Notice that that only restricts my sine function to that set interval. Next, let's take a look at the Table tab. Navigate up and over to Table. Notice here we have three columns, x, f of x, and g of x. It is important to note that even though we restricted the plot of g of x, we are still finding values outside of that 0 to 2 pi range. Restricting the plot only restricts the graph, not the function. Here in our table, we have a couple options. You can toggle on the exact results. You can even set the interval. Setting the interval allows you to pick which x values you want to start with, end with, and the step size. Since I have a trig function graphed, I'll start at negative 2 pi and go to 2 pi, and I'll do increments of pi over 2. Now we can see that our x values have updated as well as our g of x and f of x values. Another way to edit the table is to input values using your number pad. For instance, if I was interested in negative 100, I can type in negative 100, press execute, and my table will update. The last thing I'll show you in your table is how to also access your options for your functions. If I go up and over to my f of x function and press OK, you'll notice that we're in that same option menu from before. We can change the color, we can toggle on the value of the derivative again. I'll do that here, and then we have those same options from earlier: plot restriction, show graph in table, and delete the expression. Now that I've toggled on the value of the derivative, let's head back and see what that does. You'll notice in my table, not only will I have f of x, but I'll also have f prime of x. This is great for creating sign charts. And then, because I've toggled on my derivative, in my graph tab, if I am tracing my quadratic function, which I've toggled on the derivative, you'll notice the bottom banner will also include the value of the derivative. All right, let's head back to our expression tab and take a look at some of the other things that we can do. I'm going to leave our f of x function for now, but I'm going to delete my sine g of x function. I'll just hit clear to do that. I'm going to add another function, g of x, but this time I'm going to make it a transformation of my f of x polynomial. I'm going to press OK and grab my g of x equals x function template again. I'm going to clear out my x, and I'm going to use my var key to access my stored f of x function. Here in my var key, I'll go into functions, and I'll grab f of x, and I'll input an x. Now that g of x is equal to f of x, I can manipulate this to create a transformation. For example, I'll do a reflection, a vertical stretch, and I'll also shift this to the left 4 units. Now that I've created my transformation, I can look at my graphs to compare my two functions. You can also do the same concept on g of x. I'm going to clear out what I currently have and make g of x the derivative of f of x. To do that, use your toolbox to access your calculus submenu and tell it to find a derivative. Now use your var key to say that we're finding the derivative of our f of x function. So we're finding the derivative of f of x, and we're evaluating this derivative at x. This again creates the derivative function so that you can graph both the original and the derivative to compare. Here I'll turn on my auto zoom. It's also worth mentioning that this var button works across all applications. You can find f of 5 in your calculation app, or find when f of x equals 0 in the solver app. For example, let's do that solving. I'm going to press my home button and go over to my equations and press OK. I'm going to add an equation, and I'll use my empty template here. I'll do a var, grab that f of x, press OK, input x, and then I'll set this equal to 0. So shift pi 0. Shift pi gives us our equal sign, and then press execute. Now I can go down and solve this quadratic equation, and it will give me my exact values of my roots. Now let's take a look at some other expressions that we can graph. Let's hit our home button and go back to the grapher application. Let's clear out everything we have. This time, rather than use a template, I can also start typing right away. We're going to add a line in standard form. Let's do 3x plus 4y equals 12. To do this, I'm going to start typing 3, use my X and T button, plus 4. To get y, I'll use my alpha key followed by 3. To get equals, I'll use shift followed by pi, and we'll set this equal to 12 and hit execute. Some of the expressions that we have additional information for. We're going to look, before we even graph this line, we're going to look at the options. You can access the options of a function from the expression tab by going over to the 3 dots and pressing OK. You'll see the same options that we had below for our functions, but for this line, you'll notice a details at the top. Press OK to open the details of this line. In the details of this line, it will tell us that it's a line, that another form of this equation is y equals mx plus b, and it will even tell us those parameters, m and b, for our given line. At this time, we offer details for all lines and conics. For example, let's add a conic and see the details. I'm going to add an element, and this time I'll scroll down to use my conic template. Press OK. I'll add a few coefficients to create my conic. Once you have the conic template updated, press OK. You'll notice that it updates to express what type of conic it is. So we're looking at a hyperbolic curve, and we'll go take a look at the details of this. So go over to your three dots to open your option. Press OK on details. You'll notice that we show our type, A, B, and C value, as well as our eccentricity and our center coordinate of the conic. Let's go back and look at our graph of these two. Let's look at the graph of these expressions as well as being able to trace on our line and our conic. Let's go back to our expressions, and we're going to turn these expressions into inequalities. Let's edit our existing expressions, and we'll create the line to be 3x plus 4y is less than or equal to 12. To create the less than or equal to, navigate to before the equal to and use your shift square root button to create a less than symbol. Pressing OK, you'll see your inequality update to a less than or equal to. For our conic, let's just make it a less than by deleting the equal sign and using shift square root to create our less than symbol. Let's take a look at these graphs. Here you'll notice our solid line for our linear and our dotted line for our conic, as well as the appropriate shading. Pressing OK on the inequality, you'll notice that we have our editable x and y values as well as our options. It's important to note that right now we don't have a find menu for inequalities, conics, inverse relationships, polar or parametric functions, but we hope to in the future. Let's head back to our expression tab and discuss our piecewise functionality. Clearing out everything we have, I'll add an element, and this time I'll use our piecewise template. This piecewise template works just like our matrix template. So when you're in edit mode, you'll see the gray options down at the bottom that are optional to add, so that you can increase your number of pieces in your piecewise defined function. In your template, you can edit the pieces so that they are the functions that you want. For example, I'll do negative x squared minus 4 for my first piece. For the domain of my first piece, I want this piece to be used on the domain when x is less than negative 2 or when x is greater than 2. So let's take a look at how we can do that. First thing I'll do is I have my x is less than 0. I'll clear out 0 and add a negative 2. To get the OR functionality, I'm going to use my toolbox and then navigate all the way down to my logic section. Within my logic section, I have many things to help me write my piecewise equations. For this problem, I'll use my OR feature. Now, I'll say when x is greater than, I'll use my shift x squared button, positive 2. For my second piece, we'll do a positive x squared, and we want this between negative 2 and positive 2. I could just clear out my domain. Our functionality says when it's empty, it will do an other. So this will do everything between negative 2 and positive 2. Or I can write it as a compound inequality. So I'll say negative 2, use my toolbox again to get my less than or equal to x, which is less than or equal to 2. And now I've created my piecewise function. Again, let's take a look at our graph and zooming out to see our piecewise. The last thing that we'll look at is some of our advanced functionalities. Let's go back to our expression tab and clear out our piecewise function. This time we're going to add a parametric and a polar. Pressing OK to add an element, navigate down to our parametric template. This gives me a parametric template where I can edit my x and y values. Here in this parametric, the first element is your x of t. So for this, I'll do cosine of 5t. My sine of t is my y value in my parametric, my y of t. I'll do sine of 3t minus 2. And press OK to confirm. I'm also going to add a polar rose. So this time I'll navigate all the way to the bottom to grab my polar template and press OK. And for this polar rose, I'll do cosine of 6 theta. One important thing to note, if you accidentally delete your theta button, you can add it back quickly. Since we're in the polar template, our X and T key will act as a theta. The same would be true for our parametric. In a parametric equation, your X and T button would act as the T variable. We can press OK to confirm this polar rose, and we'll go down to plot the graph. Looking at our polar and our parametric, we can trace our curves and navigate between curves for different theta and t values. Taking a look at the table of values when you have a polar and a parametric graph together, you'll notice that we have a theta, the polar column, the t column, and the parametric column. The last thing that I'll mention that we can handle in our expression tab is vertical lines. To add a vertical line, simply type x followed by shift pi to get your equals, and we'll do 5. This will graph a vertical line at x equals 5. Thank you for watching this webinar. Please don't hesitate to reach out if you have any questions, and visit numworks.com for more tutorials, webinars, and resources.